I'm thinking of two numbers. The sum of the two numbers is 164. What are my two numbers? What are my two numbers? What are my two numbers? Do we know what my two numbers are? If we don't know what our numbers are, how do we represent our numbers? With what? With a variable. And so what variables would y'all like to choose for this problem? X and Y. Would that be a good numbers? Good variables? Okay. So they're telling me the sum of my two numbers. So this is my first number. This is my second number. The sum of my two numbers is what? So how could I write an equation? X plus Y equals what? Okay. Now, with the information that you have now, go ahead and write your second equation. Solve for your numbers. So we wrote our first equation. Now we're going to write our second equation. Now we're going to use the systems of equations that we've been learning about, and we're going to utilize that to go ahead and solve for the answer to the riddle. Who would like to share the second equation that they wrote? Second equation. Cooper. X minus Y equals 358. Who agrees with Cooper? That should be our second equation. Okay, cool. Now from here, what do? How do we start solving this? We have to do what? We could do elimination, or we could do what? Substitution. Does it matter which one? No. So which one do y'all want to work with? Elimination. Why do you want to work with elimination? Because it's got a plus y and a minus y. That means that we already have one that can be eliminated. So if we add them together, what's x plus x? Y plus negative y? Y plus negative y. 0. 164 plus 358. 5 what? 522. Now what do? Huh? Divide by 2. Okay, so what's the value of x? Huh? 261. Can you take the value of this one and plug it back into an equation to solve for y? Yes, you can. So let's go ahead and plug it into the first one because it's positive. So 261 plus y equals 164. Now what do we have to do? Subtract 261 from both sides. So the value of y equals what? What? Negative 97. Okay, so we know that our first number is 261, and we know that our second number is what? Negative 97. So his numbers are 261 and negative 97. Okay, let's look at number 3. This is what we're doing the entire time that we're doing this whole situation. So, we are going to be working through problems where we are reading an equation. When we read the equation, we are figuring out what is our variable going to represent. From there, we are going to figure out, exactly like we did when we wrote our word problems, back when we were solving equations, but now instead of having one equation, we have two. So we're doing the exact same thing that we were doing a few modules back when we were solving equations by using words, but now we just have 2, and we're trying to figure out what's going to work. So everybody look at number 3. We're looking at number 3 on page 142. And I want you to read what it says. So everybody, let's read it out loud. One number is 6 less, let's try again. Everybody, read it out loud. Ready? One number is 6 less than 2 times another number. The sum of the two numbers is 6. What are the numbers? Write and solve a system of equations to find the two numbers. Okay, so did you know that reading out loud helps your brain to hear what it's saying? Okay, so let's read it one more time. I'm going to read it out loud, but I want you to read it quietly to yourself just so that you can listen one more time. One number is 6 less than 2 times another number. Okay, so stop. Do we have information? Okay, so we know that one number. Do we know what our numbers are? No. How can we represent our numbers? X and Y. So I'm just going to put X and Y over here in the corner just so that I can remember that I'm working with X and a Y. But it tells me one number is 6 less than 2 times another number. Okay, one number is. How can we represent that? What do we like to work with better than X? Y. So let's work with our Y. So Y what? What's is mean? Equals. Y equals. Okay, ready? 6 less than 2 times another number. Question. Anytime we have a less than or a more than, where does it go? At the end. It goes at the what? At the end. So minus what? 6 at the end. 2 times another number. What's our other number? 2 times X. Doesn't that look more familiar? Yes? Okay, now we have the sum of the two numbers is 6. What are our two numbers? X and Y. So X plus what? Y equals 6. I want you to spend about 2 minutes and solve this system, please. The hardest part about this is working through and figuring out what your equations are going to be. So how do we represent our two numbers? There you go. Is 6. No. The sum of the two unknown numbers equals 6. There you go. There's two options that you could do for this. You could substitute or you can eliminate. I'm going to substitute because it's already solved for Y. So all of this gets to go here. X plus 2x minus 6 equals 6. Add 6. X plus 2x is 3x's equals 12. X equals 4. So if you know that x equals 4, 4 plus y equals 6. 4 plus what equals 6? Minus 4 minus 4, y equals 2. Yes? So we know that our two numbers are 2 and 4. Okay, let's look at number 4. So we're going to write our own I am thinking of two numbers riddle. This is what we're going to do. You're going to choose two integers between negative 100 and 100. So ready? Hide your answers. You don't want your neighbor to see. Hide your answers. And I want you to pick two numbers. Okay, now you are going to write a riddle. Now I'm going to give you a sum, like an example. So my riddle, if I was saying I was writing a riddle, I would say I am thinking of two numbers. The sum of my two numbers is negative 7. The difference of my two numbers, you're not writing what I'm writing. I'm giving you an example, is 43. What are my numbers? So, you are creating a riddle. I'm going to give you my numbers because you're not doing my numbers. So I'm taking my two numbers and I am thinking of two numbers. That means that the sum of my two numbers, 18 plus negative 25, x plus y equals negative 7. But if I subtract my two numbers, x minus y, I get 43. So you are going to write a riddle for your neighbor. I'm going to give you an index card, and you are going to write it on that index card, and then you're going to share it with your neighbor after you're done figuring it out. So you are writing a riddle for your neighbor. I don't know, I'm going to pick negative 25 and 24. Those are my two numbers. So I know that negative 25 plus 24 equals negative 1. I also know that negative 25 minus 24 is going to equal negative 49. So in order for me to write this equation, x plus y equals negative 1, x minus y equals negative 49. This is my system of equations. This is not a difficult task. This is me taking two numbers and adding them together, x and y, x and y. So, your job right now is to solve the system of equations that you were handed. If you were not handed anything, write them an encouraging note. So solve their systems of equations or write them an encouraging note. Let's look at number 5. We're going to look at number 5. So we're using prior knowledge from our geometry lesson where we know that parallel lines that are cut by a transversal tell us things about our values of our angles. So we know, just by looking at this, we know that what equals what. Let's look at the equation. Let's look at the diagram that they gave us. Look, so Joel says that these two things are equal because they're what kind of angles? Vertical angles. So we automatically know that y equals 3x minus 48. We know this because we know that vertical angles are congruent. They're the same measure. Now, what other information do we know? What other information can we figure out by looking at our diagram? Hold on, Christopher. I want everybody to look at it. Hold on. I want everybody to look at it. We have 3 minutes. Find an answer. When you have your answer, I want you to stand up. Be prepared to answer. Yeah, you may solve it. We have to figure out some more information. We have to solve this system of equations. So you're trying to find another equation that could be true based on the information that is on your paper. Using the information that they have and what you know about solving anything with parallel lines. And while you're standing up, go ahead and try to solve for it. What other information do we know about this problem? Way to give up. Perseverance, guys. Perseverance is a gift. Yes, sir. What both of them combine?
Y and 3x minus 48.
No, this and this don't equal 180. X and Y equal 180. We know that this plus this equal 180. So we know that X plus Y equals 180. Why? Because this and this are, what kind of angles? What kind of angles are these? They're corresponding angles. Good job. So these are corresponding angles. And we know that this angle and this angle are both on a line, so they have to equal 180 degrees. We're going to finish the lesson tomorrow. Okay, we know that this angle right here, we went over this a little bit yesterday, didn't we? This angle and this angle are what? Vertical angles. So we know that y equals 3x minus 48. We know that because they're congruent. They're the same. They're vertical. Vertical means the same measure. What else do we know? We had figured out something else yesterday. What did we figure out? X plus y equals how much? X plus y equals 180. We can figure out the value of what? What do we need to figure out? The value of x and y. So, in order to do that, what can we do? Substitute. What can we substitute? We already know the y value. Do we not? So I want you to go ahead and set up this equation. Go. Solve it. So we know that x or y equals 3x minus 48. And we also know that x plus y equals 180. So we can substitute our y equals into our equation and solve and see that x equals 57 degrees. We can plug that into our other equation and figure out that y equals 123 degrees. Any questions? Yes, ma'am. 58, 124. Did I make a mistake? Okay, so you made a mistake in just adding or subtracting or dividing. Simple mistake. Did you write the wrong number down? Okay, let's look at the next one. 6, 7. I want to go over, I'll give you the answer to number 6 for those that did number 6. So two angles are complementary. X plus y equals 90. The measure of one angle is 10 more than 2/3 the measure of the other angle. That means that the measure of one angle is 10 more than 2/3. So 2/3 x plus 10. Am I setting it up right? Equals what? Equals y, right? Yes? 2/3 x equals y? Just making sure. I'm double checking. Yeah, that's what I thought. Okay. I think I did it backwards. Plus 10 equals y. That works. The book did it backwards. So, y should equal 48. X should equal 42. How'd y'all do? You did okay? It's okay if you did it backwards. Oh, sorry. It would be that way. I just went by the book because the book did it backwards and I did. Okay, everybody look at number 7 though. That's what I really want to go over before we leave. Real quick, your homework in my class is going to be page 177 and 178, 1 through 3. And page 156 and 157, 4 through 6. So 157 and 158, 4 through 6. Sorry, 156. 156, 157, 4 through 6. And then the other was 177, 1 through 3. Okay, the length of a rectangle. Rectangle, here's our rectangle. The length of the rectangle is 4 times its width. What's our width? What's our width? What's our width? The width is this one, right? What do we know about our width? Do we know the length of our width? How do we represent our width? No, that's the length. The length is what? 4 times the width. Guys, we have length and width of a rectangle. Yes? Okay. We have length and width of a rectangle. Yes? Do we know the width? Did they tell us the width? So how do we represent the width? With a W. We can just leave the W. But they did tell us that the length was what? 4 times the width. And then they tell us that the perimeter is what? All the way around is how much? 45 inches. So that means that 2 times the width plus 2 times the length equals 45. But we know that the length equals 4 times W. So what does that mean that we need to do? Substitute 4W into the L. So that makes it 2W plus 2 times 4W equals 45. So the park charges $18 for each adult ticket. How much? $18 for each adult ticket. That's important information. And then how much? $13 for each what? Okay. The class president calculates the cost for $2,660 for all adult students and adult and student tickets to the park. How many adults and how many students are going to the amusement park? So this is what we need to know. We need to know how we are going to label our variables. So we need to know how we are going to represent our variables. What does it mean when Ms. Gode says represent our variables? Well, we're trying to find unknowns, right? Yeah, which one's going to be our X and which one's going to be our Y. Okay? So, you need to be a good friend. So, which one's going to be our X and which one's going to be our Y? So, what do y'all want as our X? Students. Do y'all agree with Cooper? Okay, and which is going to be our Y? Adults. Okay. Now that we have the idea of what our students and our adults are going to be, we now have to set up an equation. So what kind of equation do we need to set up? Well, we have to set up what kind of equation? A linear equation. Because there is a relationship going on between these the tickets and the price, right? So it's a linear equation. What must we do to set up this equation? Let's take the information that they had and do something with it. Ready? So they said it's 18 for each what? Adult ticket. What are we representing our adults by? Y. Okay, so what does it mean 18 for each? 18 times Y. So 18Y. And then what? Plus 13 what? 13x, okay? And that's going to equal how much? 2,660. And what information are we looking for? How many adults and students? So what would we do? What are we looking for? The total, right? Okay, so what would we do to solve this problem? So what I want you to do is I want you to spend 2 minutes and work with your group to see if y'all can figure out how to figure out how many adults are going to and how many students are going to. Go. What kind of equation is this? A linear equation. So that means that it's going to make a what? It's going to make a what?
Hello? Yes.
Well, we could put it in slope intercept form, but what do we know? We know that we could have a certain amount of what? Adults and a certain amount of students. What happens if no adults went on the trip? Could you figure that out? Could you also figure out what if no students went on the trip?
Yeah.
That would be kind of funny, but if no students went on the trip, you would have a bunch of adults, right? So you could at least figure out, if we look at this logically, we could figure out how many students and how many adults went on the trip based on its intercepts, where it's crossing the x-axis, right? We could do that if we wanted to. We can multiply this times 0, and then 18 times 0, and then figure out how many x's would be there. Or you can multiply the x times 0 and figure out how many y's would be there. But ultimately, do we have enough information to figure out how many people are there? No, we don't have enough information. So we need additional information in order to be able to figure this out. This is why we use systems of linear equations. This is why we are doing systems in the first place. So everybody look at number 2. Read it to yourself while I read it out loud. A total of 190 people are going to the amusement park for an end of school year field trip. The park charges $18 for each adult ticket and $13 for each student ticket. The class president calculates the cost of $2,660 for all adult and student tickets to the park. How many adults and how many students are going to the amusement park? Well, what do we know now? We know how many people are going, right? We know the total of people that are going, right? So that changes things a little bit. Now we have how many equations? We have 2 equations. Our first equation is still this one. That's still our first equation. But what's our next equation? Yes, sir. Y plus x equals 190. We now know that we have the amount of adults plus the amount of students equals 190. So from this step, can we solve and figure out how many kids and how many adults went to this amusement park? Okay, I'm going to give you about 2 minutes as a group. Go ahead. What was our solution? How many adults did we have? And how many students did we have? So how many adults? 18 adults. Okay? And how many students?
Oh, no, wait, sorry.
Okay, so class, how many adults did y'all get? Okay, we have 38. Anybody disagree or agree? Are we not done yet? Okay, so let's look at it. What did y'all do first? Let's finish it together as a class. Okay, Marley, what did you move? The first equation or the second equation? Second one. So you subtracted x from both sides?
Yeah.
So Marley moved the second one just because it probably looked easier. So now she gets y equals negative x plus 190. Y'all agree? Yes or no? Okay, from here, what do I do? I can substitute. I can take all of this information and I can plug it into that other equation where there's a y. So that means that I now have 18 times negative x plus 190 plus 13x equals 2660. We're going to multiply 18 times negative x. 18 times 190. Plus 13 x's equals 2,660. Ready? What's negative 18 x's plus 13 x's? Almost what I did was do what? Combine my terms. Okay, now what do I do? Ooh, 420. Okay, so negative 5x's equals, what's 2,660 minus 3,420? Negative 700 and what? 60. Now what do I do? X equals what? 152. So that means that I have 152 students that are going on the trip. But then I need to do what? Figure out how many adults. So I'm going to take this value right here and I'm going to go to the easiest equation that I have. Y plus X equals 190. However, I already did what? I already put it in y equals mx plus b. Y equals negative x plus 190. I can take this and say y equals negative 152 plus 190. What's negative 152 plus 190? Y equals what? 38. So that means that I have 38 what? And 152 students. Yes? Okay, why are we looking at me like y'all have never seen this before in your life? Y'all good? Let's go to the next problem. The arcade. So he and Ethan are at the arcade in the amusement park. They play a game in which they earn points by collecting coins and gems. So he collects 3 coins and 5 gems for a total of 70 points. Ethan collects 6 coins and 2 gems for a total of 52 points. How many points is 1 coin worth and how many points is 1 gem worth? So we are going to now set up a situation. But what information do we need to know to solve the problem? Yes? Okay, so this is important information. Yes? What else do we need to know? Ethan's collecting some over here. Okay, can we use this information to be able to figure out how much each gem and how much each coin is going to be worth? Okay, so making sure that we all have the same variables. What do you want our gems to be? Y. Okay. Y are our gems. Okay, so that means that X is our coins. X's are coins. Okay, ready? And you and your group, I want y'all to set up a system of equations and solve for our gems and our coins. Go. This is where Ms. Godet is. So I used elimination. And the reason why I used elimination is because I saw how they lined up. And I was like, okay, cool. Look, if this is a 3x, I can multiply it times a negative 2. And I can eliminate those x's and solve for my y pretty quickly. So if you use substitution, great. If you use elimination, there's a reason why I taught you those 2 different methods. Because you're going to be able to do that. So however which way you did it, I'm not done solving this one, but y equals 11. So that means that your gems are 11 each. And then to finish this, 70 minus 55 is 15. X equals 5. So that means that your coins are 5 each. Does that make sense? Okay, so ready? Here we go. Look at number 4. The class president lost the lunch receipt. Oh no. Here we go. She knows that there's 21 students that ate lunch and the total cost was $117.27. Each student ordered either a $4.99 sandwich meal or a $5.95 pizza meal. The sandwich meal included one sandwich, one small order of fries, and one medium drink. The pizza meal included 2 slices of pizza and 1 medium drink. Question. Do we even need the last 2 sentences? No. They're just extra. You do not need those extra sentences. Do not get confuzzled whenever they give you a bunch of extra information, okay? Unless they're asking you how many things of fries they had, don't worry about the last two sentences. Those are not important, okay? They gave us all of this extra stuff. We don't need this. Do y'all understand that? I need you to understand that because you're going to go and read it and you'll be like, there's so much more information. It's called extraneous information. It's not on it's on purpose. They gave it to you on purpose to mess you up in your brain. Okay? We're not trying to be messed up. We're trying to figure out how to do this. So, how many of each meal was ordered? Let's go ahead and set this up. We know that how many people ate lunch? 21 people ate lunch. So, we're going to do X equals sandwich. Y equals pizza. You okay with that? What's up, Christopher? No. See how it's blinking? I hope not. Nope. We're recording. See how it's blinking? We're blinking. Okay, we're good. So, set it up. We need to make sure that we have 2 equations. Really? We're setting up our equations. We know that we have how many students? 21. So how can we set up our equation stating that we had 21 students? Well, certain amount had pizza and certain amount of them had sandwiches, right? So how can we write that equation? X plus Y equals 21. Don't make this more complicated than it needs to be. That's the simple part. Now we're going to take the other information that they gave us. So we know the total cost was how much. We know that each one was the sandwich meal, and then we know that this one was the pizza meal. So how do we write it? If X is sandwich, how much is that per sandwich? $4.99 times X. Okay? And how much was the pizza? And how much was the total? Okay, are we okay where we are? Beautiful. Now, what's the easiest way to solve this one? Is it by elimination or by substitution? Substitution would be the easiest way to solve this one. Why? Because it's got a bunch of decimals and whatnot. Like, you just do the math part. Okay, so do y'all want to solve for X or Y? I like to solve for Y, just because my brain sees it. So, let's move this and adjust this. So how do I adjust this? I have to subtract something. What do I subtract? X. The X, okay. So if I have X plus Y, I subtract X from both sides. I now have Y equals negative X plus 21. Guys, when I subtract, all I'm doing is moving this negative X to the other side so that I can have Y by itself. We're just moving him over. And 21 and negative X can't go together. They're not the same terms. So now I can take this information right here, and anywhere there's a Y in the other equation, I can substitute it. Because I'm trying to solve for one of them. Okay, so if we do the math, go ahead and do it. See where you get. Okay, let's look at the step that we're at. So if we look at the whole thing, we're seeing that we had 8 people that had sandwiches and 13 people that had pizza. When you work through it, you're going to figure out, combine like terms, subtract what you need to, solve for the value of X, plug it back in, and solve for the value of Y. Yes? Are we okay right now? Cool, because we're going to go all the way back to page 145. All the way back to page 145. Because now everybody's face went. We know how to do geometry. We know what geometry is. We know about parallel lines. We know that parallel lines give us special angles. We know how to solve problems like this. We just have to look at all of the pieces that they've given us and figure out what we don't have or what we need in order to be able to solve this correctly. We're doing the exact same thing. Systems of equations. So what do you see in the problem? You see X and Y. What else do you see?